In our last video, we looked at the synchronized keyword and using that on a method. In this example, we're going to take a look at this at using synchronized statements, which is essentially the same thing. It's just more explicit. So we have the ability to use the synchronized keyword to make a synchronized block. And inside that synchronized block, we can put some more statements. So when we call synchronized, the expression has to evaluate to an object reference. So we have to pass synchronized an object. If the object is already locked by another thread, it's blocked until the lock gets released. When a lock is obtained on the object, the statements in the synchronized block are executed and then it gets released. So it works the same way we described in the last videos. So let's take a look at well, here's the example we did in the last video. We just added the synchronized keyword to a method that we already had. That's the exact same thing as doing something like this: public void and then naming the method, and then calling synchronized, passing this, which is an object reference, and then writing the method body here. Two ways to write the exact same thing. So a synchronized method like we did was implicitly acquiring a lock. So all we did is put the synchronized keyword in there, and it automatically did the lock for us and released the lock when it was done. But we can also use locks explicitly. So we want to talk about how do we manually make a lock. So the new locking features are flexible. They give us more control for coordinating threads, which is ultimately where we're going with this. A lock is an instance of the lock interface. So Java has a lock interface that specifies anything that's a lock must have a lock method and an unlock method and a way to make a condition. The concrete class that we actually use in Java is called reentrant lock, and it implements this interface. So kind of like ArrayList implements the list interface, reentrant lock implements the lock interface. And so if we want to create a lock, we actually use the reentrant lock class. So reentrant lock is the concrete implementation of lock for creating mutually exclusive locks manually. We can create a lock with the specified fairness policy. So there is a fairness parameter we can pass. A true fairness policy basically says, hey, whatever thread's waiting the longest gets the next crack at doing the lock. If we make a false fairness policy, it just kind of randomly assigns threads, and whoever gets it first gets it first. Which doesn't seem like the fair way to do it, but there's drawbacks to making everything fair. Programs that using fair locks, and if you have a lot of threads trying to access it, can really degrade performance. But they have a small variance in times to get locks, and they guarantee you won't have a thread that gets starved out, meaning it never quite gets crack at running. So know about fairness policies, fair or unfair, true fairness or false fairness. Okay. So let's take an example of, let's look at an example of the same thing that we just looked at in the last video, except written with explicit locks. So let me pull that up. So here is the same program. Everything up here is the same. We create an account, we have an executor service, it launches 100 threads, then it tries to shut down. As soon as it's shut down, it prints out our balance. We have our add a penny task. The differences are going to come in the account class. Remember, that's where the shared resources that we want to make sure doesn't get access simultaneously. So this time, instead of using the synchronized keyword on this method, we're going to do it manually. So up at the beginning of our class, we create a lock. Okay, so it's a new reentrant lock, subtype lock. So we give it the name lock. So that's our lock that we created. We still have our balance like we did before. Get balance is not changed. When we get to our deposit method, instead of just adding the synchronized keyword there, we manually acquire the lock by calling the lock we created and saying, hey, lock this method. Don't let anybody else in here till I'm done, basically is what that says. All right. So then we add the amount onto our balance. This is in a try catch block because for this demo, we added a thread sleep 5. I'm going to change it to 1. I'll change it to 1 because I found that works better on this particular computer. Actually, if it works, you won't notice a difference anyway. And then sets the balance. Okay. And there's the end of our catch block. And then finally, as long as this completed, which it normally does, we could get that interrupted exception that we always talk about with the sleep method, which is why this is in a try catch. But at the end, we have to release the lock. So the same thing we did, except we're manually creating the lock and manually releasing the lock. And if we run it, it works just fine and it gets a balance of 100. Now, cooperating among threads. What if we have more than one thread that needs to cooperate with another thread? Okay, we don't necessarily want one of them hogging it. Sometimes one thread might need to wait on one of the other threads. So we can use conditions for that. We can specify what to do under certain conditions, and conditions are objects. They're created by invoking the new condition method, and we saw that in the condition interface. It's in there. Okay. There's also an await method and a signal method that are part of this condition interface. Once we create a condition, we can use its await, signal, and signal all methods to communicate between threads. So now our threads are going to start talking to each other to make sure things happen how we want them to happen. It's a way to guarantee that our threads are working together and not against each other. So when we call an await method, it tells the current thread, hey, wait until the condition is signaled. So it's going to wait on some condition, and once that condition happens, it will resume. Await is going to cause it to release its lock on that method while it waits for another thread to execute. Okay. The signal method wakes up a waiting thread, and the signal all method wakes up all threads that might be waiting. So let's talk about a bank account where things are getting withdrawn and things are getting deposited into a bank account. And we're going to see an example of this coming up. So let's talk about how it works first. So we have withdraw. Somebody goes to withdraw something from a bank account. We had deposit before. We're going to talk about withdraw. When we go to withdraw something from the bank account, we create a lock, okay, on the withdraw task. So we lock up the account. Okay. And then we check to see if the balance is less than the amount they're trying to withdraw. Well, if the balance is less than the amount they're going to withdraw, we can't allow them to withdraw it, right? We don't want people's balances to be negative. At that point, we're going to call new deposit. We're going to call .await. Okay. And this basically says, hey, release that lock temporarily while we wait on this deposit task. Okay. Now, the deposit task, if something's making deposits, we'll lock the account, add money to the account. Once it adds money, it's going to signal, in this case, it's calling signal all, and say, hey, I just changed the condition because I've added money to this account. And then it unlocks itself. But that signal all tells this thread, go ahead and check to see if your balance is good now. And if it is good, you can go ahead and withdraw it. If it's not good, you're going to keep waiting. So that's the way they're going to communicate with each other. We're going to create the locks manually, and we're going to use the await methods along with the conditions so that they can talk to each other. So we're going to go see an example of that right now. Here's our example that we're going to look at. This class is called Thread Cooperation. It has an account, so we're going to create a new account. And in the main method, we're going to create an executor with a thread pool of size 2. And we have 2 threads that are going to be created, one for depositing and one for withdrawing. Okay, so that's the main method. It's going to start these 2 tasks, deposit task and withdraw task. Let's take a look at those. The deposit task, which is one of our threads, so it implements runnable, okay, has a run method, and it has a continuous loop here. So while true, it's an infinite loop. So what it's going to do is continually try to deposit money in our account. I wish I had one of those at my bank. And what's it going to do? It's going to take a random number up to 10, from 1 to 10, and try to access the account from our class and try and deposit up to between 1 and 10 credits, or 1 and 10 pennies, whatever you want to think of it. And then in this case, it's going to sleep for 1,000 milliseconds. So about once a second, it's going to try and make a deposit into our account. Remember, we have the try catch block, because anytime we call sleep, we have to have a try catch block to catch it in case something goes wrong, and it throws an interrupted exception. We also have a withdraw task. The withdraw task is also going to access our account, and it's going to withdraw a random number up to 10, between 1 and 10 credits, or 1 and 10 pennies, however you want to look at it, from our account. So 2 tasks. This one is continually trying to withdraw. It doesn't have a sleep in it, right? So it's going to try and withdraw money as fast as it can. And this one's only going to deposit once every 10 seconds. So that should be interesting. All right, let's look at our account, because this is where the cooperation happens. We've talked about this before. It's very similar to the account we've seen in the previous videos and examples that we've looked at. So we're going to create a lock by making a new reentrant lock, and it's going to be called lock. And then this is where the condition comes in. So we're going to use this condition class, and we're going to have a condition called new deposit. And it's going to be a new condition based on this lock object that we have here. I do want to point out at the very top, we're importing everything from the concurrent package and everything from the concurrent locks package. Those had to be added for this to work. So always remember that. Sometimes if you try to do some of these things and you get the helper up here, it will only try to import one particular class, and you might need more than one class in this case. So be careful about that. All right, so we create our lock, we create our condition that is basically checking to see if there's new deposits. Okay. Our balance is 0, we have our get balance. That's nothing new to this class. Okay, so the withdraw method first uses the lock to acquire a lock. And then it's going to try. It's going to check to see if the balance is less than the amount they're trying to withdraw. Okay. And if it is, it's just going to print out, hey, let's wait for a deposit. And then it's going to call new deposit dot await. So it's using this lock condition and telling, hey, this condition, we're going to wait. Okay, which releases the lock on the account temporarily. Okay, waiting for the balance to be greater than the amount. Everything else here works about the same as we would expect. Once it does get released, it's going to subtract the balance and print out the new balance. Okay. Here's the deposit method. The deposit method also acquires the lock. Okay. And the deposit method is going to try to add the amount onto the balance. Okay. And once it does, it's going to signal the condition, new deposit. It's going to signal all the threads that are waiting. In this case, the only one that we could have awaiting is the withdrawal method, and say, hey, we've made a new deposit, and then it's going to release the lock. So let's see what happens when we run this. Now, it's a continuous loop, so let's stop it right here. I'm just going to stop it. So in this column, we have thread 1. Okay, so we're using tabs here to make our columns. In this column, we have the communications from thread 2. And over here, we can see the balance, which is kind of the shared resource. Those two methods are the shared resource, the balance of our account. So we have a deposit of 3, which makes our balance 3. Then thread 2 must be trying to make a withdraw, but there's not enough money for it to withdraw. So it just says, I'm going to await deposit. And that's what happens. It calls this new deposit dot await. Now I just lost my screen. All right. So similar, this time it deposited 4. Either way, thread 2 had to wait for a deposit. And then deposit, we're depositing 6 credits here. So our balance is now 10. Okay. Now, withdraw tries to withdraw 8. There is enough money there, so it withdraws it and creates 2. Okay. It tries to withdraw again, but obviously there's not enough money, so it has to wait. We deposit 10, so there's 12 now. We can withdraw 5. We can withdraw 4. So we're passing control back and forth between the two threads. Withdraw tries to withdraw constantly, but if there's not enough money, it waits for thread 1 to add more money until there is enough money, and then it tries to withdraw. And that continues on and on and on. So I've been stopping this, but we can see now we're getting those 1 second delays, remember, every time it calls that sleep method. So we can watch this happen real time. This constantly waiting for deposits to happen. Once the deposit happens, withdrawals start taking place, assuming there's enough money. Sometimes it has to wait twice before there's enough money for it to make the withdrawal. So that's using await and conditions to cause threads to cooperate with each other.